So thank you all for coming here. I understand that right after lunch, it is very tough to attend a presentation or session, right? I will try my best not to make it boring, right? For introduction, my name is Vishal Anand. I am a senior consultant in shared components and security team in Mastercard. As name suggests, like in shared components, we deal with something, or we create shared components which is used by multiple other teams inside Mastercard. You can think of things like API gateways, messaging, monitoring systems, file transfer, streaming, data flow pipelines. That comes under our purview. We have a team here in San Francisco, and we deal mostly in data flow, streaming, messaging, and things related to that. So today I'm going to start with a question like, first of all, what is a data flow pipeline, and do we really need it? Like, is it important? Well, if in today's real-time real-time processing world where everybody wants to do real-time stuff, there's still a lot of batch processes happening. You have to move your files between one system to another, one team to another, and this kind of stuff. And you want to do it in reliable and secure manner, right? And then there is one more aspect, with batch stuff, people want to do real-time stuff, and you don't want to have two different execution pipelines, right? One for your batch stuff, or one for your, real-time streaming stuff, right? What if a data flow pipeline could stream your files, your batch files, in a stream, per message way as a stream, and as an application team, you just worry about handling the stream, process it, and do whatever you want with that, right? So a data flow pipeline obviously can help in that respect, right? I'll give you another example that fits mostly in the Mastercard world. I'm pretty sure it will fit in other world as well. Think of a scenario where after a long day of work, you come home and your goal is to prepare a nice meal, eat it and sleep, right? You open your refrigerator, you have everything there. You have the right amount of water, spices, raw materials, everything is there. You just cook it up, eat it, enjoy, and sleep, right? Now you come home, and you think of, oh my God, where should I get water from? Where should I get spices from? Where should I get raw materials from? Do I have to buy a stove to build all this stuff, right? So what will happen? Probably you'll go to a restaurant, spend some money and eat it, or you'll just, sleep without eating stuff. So, it's not possible, right? So apply the same analogy to the different teams. What they want to do is they want to build a specific product, right? They have some business logic to implement. They want to, expose some services, right? But again, they need data to work with. And instead of concentrating more on their business logic, what they worry about is where to get data from, how to extract it, how to clean it up, right? So they basically, their most of the time is going towards, thinking of all those things. If you have, like in shared components, if we could build something, a reliable data flow system, so they don't have to worry about it, right? And if you think from Mastercard perspective, we deal mostly in transactions, right? So most of the time, everybody needs transactions. Somebody might have already cleared it, and added some lookup and make it more usable, right? So if you are consuming raw stuff all the time, you have to do all the things again and again, right? By giving a shared data flow pipeline stuff, you are basically stopping, a duplication of data. You are avoiding redundancy. So in all these aspects, I believe, and the data flow pipeline is a very important component of enterprise which deals with data. So, okay, we are supposed to go to this slide and talk about it. I missed that, right? Anyway. So when in shared components, when we started thinking about introducing a tool which could solve this purpose, what we did, we thought of some attributes. We call it design for X. If we are going for a particular tool or open source software or whatever it is, right? It should meet with it should solve some of these things, or it should support some of these things, either 100% or to some extent, or they should have this stuff in their pipeline. Like sometime in future they will deliver all this stuff. So we went through all the stuff, and we found NIFI was kind of supporting most of the stuff. And I'll go through briefly in detail each and everything very quickly, how NIFI supports all these things and how it helped us in taking a decision and going towards NIFI. So let's start with clustering. I think nowadays everything is either clustered or distributed, right? So the data flow pipeline NIFI stuff, it again it is a clustered solution. And when you think of clustering, you could have like different kind of cluster. It could be a zero master clustering where an entity outside your cluster is basically managing the quorum, right? There is no master inside your cluster. Somebody else is basically assigning a master for you. Or you could have like a traditional master-slave kind of architecture. You could have one or multiple masters, but again, like they are fixed in your topology. And there could be an embedded one where you have things running as an agent or a jar, as a Spark job or MapReduce world. It itself is not a cluster, but it runs inside something else. So from NIFI perspective, it supports zero master clustering, and we felt like having no master is good, and we already had like Zookeeper installations in our system, so we said, okay, let's use Zookeeper, and NIFI will work great with that. Again, when you go with clustering, the main reason is like you want to have high availability, right? You want to know, or you want to make sure like if something goes wrong, your pipeline is not broken, right? Things keep working, right? So if you think from NIFI perspective, if you have worked with NIFI before, it has processors inbuilt. Like you basically create a flow in terms of processor, right? Each processor could have a failure, right? Like so, if you are reading from a particular location and something goes wrong, what will happen? You can design a route which says if failure happens, do this, or try it again, or something like that, right? So your workflow itself is handling the failure, right? If something you can even take a decision to notify somebody and take further action. You could do all that stuff. What happens if one node goes down, right? So the way NIFI works is if one node goes down, data is there. If you can bring it up, and then business is as usual. You're not losing anything. So in that perspective, high availability and recovery, NIFI is very good in that. And one more important thing which I want to emphasize here is replay. So you are building your pipeline, right? You are delivering something to other team. You are delivering, but those guys might be like, they could be careless, right? They could lose something, right? They'll say, oh, I lost something. Can you replay it for me, right? Some other flow files, in NIFI, everything flows as a flow file, right? So you can say, okay, just send me back all those stuff. You can replay it, right? You can replay it from the workflow, and you can send them back. You have that capability in NIFI. That is one of the, I'll say, major feature in NIFI we liked about. Okay, so this is kind of interesting. When we started looking for a tool, obviously we went for this exactly once semantic, like, okay, we should have something which will provide you exactly once guarantee. But when we started looking into it, what we realized is, in an ecosystem, you cannot say this software is providing you exactly once guarantee. It is impossible. If you have multiple systems talking to each other, you have to make sure like all of them work together to provide this exactly once thing. It is not possible for one software or one tool to provide this thing. So we thought, okay, then what is next? So we thought about, okay, at least one should be there, right? So as I said, like we deal with transactions, right? So we want to make sure if you have swiped your card, it is processed, right? It is not failing, right? So we thought, okay, if something which is providing at least one should be good enough. And NIFI, they support at least one thing. Like if a node goes down, you bring it up, and the data, whatever was there, will be processed. That much is guaranteed, right? Okay. Yeah. Again, this backpressure thing is one of the a major feature in NIFI, and we also liked it. So what happens is, again, like if you have a data flow pipeline, it basically terms of processor, like processor A is processing something and then passing it to B and then to C, right? You can define the order, the files or like the data, like flow files, how they travel between one processor to another. You can say it would be first in, first out, or you can have your own customizer written, like, if you have some specific business rules, you can write that. And you can say, okay, in that order, your data should transfer from one processor to another. So NIFI provides you that capability. And the backpressure thing is like, suppose you have like a set of three processors, A, B, and C, A goes to B and then B goes to C. If there's something wrong in C, right, A and B will adjust, and they will make sure that, that the whole pipeline is not overloaded. So it will adjust the rate it is producing the flow files. That is all handled. And you can always go and stop things, stop on processor. And because there's a queues between all those processors, you don't have to worry about that your pipeline is failing or things are stuck. So whoever is passing data, they can keep passing data. And if you want to make some changes to your processor, you can always stop it, change it, and and then start it again, and it'll take it over. So. Okay, so data governance is one thing. Like when we started thinking about a tool and we talked about multiple other things inside Mastercard, almost everybody asked about this thing. They wanted to know what is happening happening out of the data, where it is flowing. In each processor, they wanted to know what happened. Like, they should be able to go and track it and trace it. So in NIFI, we have something called provenance repository, where you can always go and see what happened to your data. It gives in very low-level detail what exactly happened. Again, you could control it, who could see and all that stuff, but yeah, it goes to that level detail if somebody is looking for it. And what I felt like, in our organization, it was very important because, somebody else is going to use this stuff, and you will basically have to satisfy them, okay, we are not going to lose anything, and we are transparent enough. You can always go and see what is happening. You are in control all the time. Again, from usability perspective, if you're designing something, it should be easy enough to design a workflow, right? So from UI perspective, they have this UI where you can drag and drop stuff, you can design your things. And I'll say it is more developer friendly than a business owner friendly. We have talked to some of the product folks, they found it kind of complex. But the guys who are designing the workflows and, and who are managing it, I think it provides a lot of features for them. You can always go and stop and see what is happening. It will tell you in real time what is happening, how much data is flowing, what is the queue size, everything you can do it on the UI. From designing perspective also, you can drag and drop and do all those things. So it is quite user-friendly in that terms. And again, it also provides you REST APIs on top of it. Almost everything, whatever you can do it in UI, you could do it through REST APIs. If you want to build your own wrapper and try to do something in automated way, you could do that here. Extensibility is something, when we decided about the open source stuff, this was one thing which was always in our mind, that if you have some open source product, there is always a possibility that new features will be coming, like because community is working on it, right? And in NIFI, again, it is built off set of processors and all that, right? So people are writing processors, you can write your own processors, you can write your own reporting tasks, you can write your own controller. It provides a lot of way to extend it whatever it has. So if you have very custom requirement which is not there as part of a native distribution, you can always go and build it. We have done that. We have added a lot of custom processors and tasks to make it work for ourselves. Okay. As you said, it was built by a shared components team and used by multiple other teams, right? So we have to make sure that team A, whatever they have built, team B should not be able to see it or make any changes, right? So NIFI, the way it is built, it can connect to your LDAP and all those things, right? And you can, based on your LDAP group, you can say whoever has access to this process group, they cannot access to something else. So you can control onto that level. So multi-tenant is something which we are looking for, and we found a great support in NIFI. Okay. Again, this is very important because when you are building something for enterprise, you want to make sure you follow all these practices, right? You don't want to go and do everything on the production environment, right? So what you do is you design things in your dev, and there should be a way to propagate it to the high environment. So we are building our own Jenkins pipelines, so that you can, and we integrate with the NIFI registry. So registry is a very cool thing here. What it does is you can build your flows, and you can again save it in the registry, and some other cluster could pull it from there. One good thing about registry is if you have designed your workflow in a good way, there is a term called process group in NIFI. So you basically group all your processes in a process group. And if you have done it in that way, you can just go and update one particular process group. Your whole pipeline will work as it is. You don't have to stop whole your pipeline to do an update. It's not like you have to bring a cluster down to make any update. You can do that with NIFI registry. Just update it from there. If there is some change, your whole pipeline will keep working as it is. And it's not just workflows, right? You also have to think of how you are deploying your custom stuff, you have custom processors or custom services or controllers. So again, we are in process of building our Jenkins pipeline, which would take it from your Git or whatever repository you use and deploy it in NIFI without stopping the cluster. So NIFI does support those kind of deployments as well. Again, so I think this is my. This is something everybody will talk inside Mastercard, things start from security and still security, right? Everybody will say, how secure is your cluster? What all things you do with, when it comes to security? We were told like NIFI was initially created for one of the most secure organization in United States, right? So it was basically solving a lot of problems for them. So what I feel, what we found is it already, has a few things inbuilt, like, even the node stock as, on a 2 SSL stuff. So from security perspective, there's a lot of stuff inbuilt. You don't have to worry about it. You can always go and control who could see what, right? And even on the UI, what is happening, because you can always go and track, what happened in your processes. You can control that. What happens in our pipeline, we deal with PCI API data, right? So what if somebody goes and just right click and just see what is there, right? You can obviously control that, right? So all those mechanisms are there. And and again, you can specify like after 6 hours or 1 day or 2 days, something your data will be deleted. So you don't have to worry about the GDPR thing. Almost each of the companies these days, they have to worry about the GDPR thing stuff, right? Okay. Again, monitoring is very important for any tool in the enterprise, right? You need to know what is happening with your tool or software, whatever you're using, right? So if you have installed NIFI using Ambari, it already provides you a basic, what you can say, a metric dashboard, like what is happening. But if you have your own custom stuff, like custom dashboard, you'd want all the metrics to be pushed from NIFI to your own custom dashboard. NIFI, as I said, like NIFI provides you the ability to write your own reporting task. It already comes with some of the stuff. You can build your own, if you want to write to Splunk or something else like that, you could do that. We have our own custom solution, and we have built a reporting task to publish metrics to that. Okay. So from integration capabilities perspective, what I mean is, you can read from multiple data sources, you can write to multiple data sources, right? It supports a lot of data sources in that way. It has processes like you can create a web service out of it, right? And if you have to create a pipeline where you are reading some stuff, you are calling a Spark job or something like that, it can integrate with all those stuff, right? NIFI provides a way you can connect to Spark streaming and basically transfer all the stream to Spark and let a Spark handle it. If you don't want to use Kafka, you can do this in plain NIFI. It is possible. And in one of the use cases, I will show like how we are using this machine learning capabilities. Like we have one use case where we are connecting some of the machine learning models and doing things through NIFI. Oops, sorry. Yeah. Again, like cloud native thing is kind of important these days. Everybody wants to have things Dockerized or be using Kubernetes support for that. I think NIFI is kind of low in these terms as of now. They do you can do a Dockerized instance of NIFI, but from Kubernetes perspective, the way it is designed right now, I feel it is not there. But I have seen like community is already working towards it, and we are also working in the community. Like if we could provide this support, right? If that is there, I think that will be a one good thing to have. Yeah, but from other than that, like if you deploy a processor or something, obviously you can do that without stopping anything. Okay, from a performance perspective, it is I think NIFI is already tried and tested to handle thousands of records per second. We didn't have to do that workspace because we know that it is already there. It does that. If you see the architecture, it is very easy to scale up, and they have something called NIFI, which could run even on a Raspberry Pi. We don't have a use case of Raspberry Pi, but if somebody wants it, you could use it. And I have seen some of the use cases where it is used in IoT world, and it is installed in that low-level machines, and things are working out with NIFI. And there's one more thing here, which is what I mean by thread model is, suppose you have like a 3-node cluster, right? And you have a processor. So you can think of at one point of time, only 3 instances are running. It is not like that. You can specify number of threads for a processor. So even with like 3-node cluster, you can come up with 6 parallel instances running in NIFI. So you can handle that load, given you have resources available on your nodes. So this is kind of just nutshell, like how we came up with a decision with NIFI. We went through all those design for X attributes, and we found okay, NIFI was supporting most of them, and that's why we started developing our use case in NIFI. So let's talk about some of the use cases which we are solving using NIFI. So first is a file transfer. Like as I said, like in our world, and I'll pretty sure like a lot of other companies, we have a lot of batch process still there, right? So files are landing from outside third parties, right? They land in your system, and now what? Like there are multiple different teams where you have to transfer that file, right? It could, it could be like Hadoop, or you want to break it up and put it into a database, or somebody might want it as a stream, right? So you can do all this stuff with NIFI, and we have this file, and this is a different team which basically handles file transfer. So we are going to support them in a way that when file lands, if you see here, right, they will trigger a NIFI workflow, and NIFI will basically do all the transfer, or transferring it to Hadoop or database, or creating a stream out of it. Some teams might have a different kind of, or you can say a custom logic. They could come up with their custom flow, and again, it will be integrated in this same system, and it's called by the same file transfer controller, by giving that, hey, this is the workflow name, take the file from this location, this is the file ID, and transfer it to this database, this table or something like that, or transfer it to this Kafka topic in this way. So all those things are configurable through a web service. I'll give you an example. So this is a dev snapshot of what we were trying to do. You can see like we have exposed some web services out of it, and the file transfer controller is basically calling the web services. And all these processes, these are like complex flows inside it. Like these are all process groups, and they are calling based on the names, like whatever workflow name they have passed, it will call that particular workflow. And when things are done, it will give you a status back. Like giving a status is very important. Like they need to know what exactly happened, whether there was some error or some issues happened and all that stuff. So it gives you a status back. It could be like calling a URL, or sending a message to a Kafka topic, and that is all we are doing here. So let's go to another topic, another use case here. There's something called data service. I explained what it is. Everybody here, I think most of the companies, they will have some sort of warehouse, right? We also have like terabytes of data there. Not just like Hadoop, we have like Hadoop, different databases and all those things. Collectively, we call it warehouse, right? And then there are like, teams outside data warehouse which they want to query it, like for different regions. Like we have a revenue stream which basically works on just querying data and providing some intelligence to outside world, right? So they basically give the requirements, and there is a team which creates models on top of this data warehouse. So they don't have to worry about whether it is Hadoop stuff or it is a database or something else, right? So the modeling tool is creating model and hides all the details behind it. And then what we have done in NIFI is we have created a flow where, again, we are exposing REST service. Somebody could call a REST service. So again, the modeling tool could work in two different ways. It could be like a real time. So you send a query, and if the response is like small and it could be handled in like in few seconds, you give the result back, right? But some of the queries, they will take long time to run, and the results will be like in GBs, like, and they want it to be transferred to a file transfer service or to a particular Hadoop cluster or something like that. So that obviously cannot be handled like a real-time REST response. So in real-time REST response, it goes through NIFI, it makes a call to the modeling tool, and it gives you the response back. It is returned back to the caller. In batch mode, what it does is it calls the data modeling tool, and this time instead of getting the result, it gets the query which has to execute. And then NIFI takes that query and basically executes it to like whatever data source it is, and then gets the result and transfer it to the intended location. It could be Hadoop or file transfer, whatever it is. So both of the stuff we have handled through NIFI. The problem was, a lot of authentication authorization thing has to happen through, data modeling tool. So I'll just give you. It looks like it's a bit kind of complex, but again, this is a dev snapshot of the data as a service thing. You could see like, a request will come in, and then we handle all the authentication and authorization piece for the modeling tool. And based on the request, it could be, we decide it is a real time or it is a batch mode, and then we, and take it further and respond back. Hopefully it is readable. Anyway. Okay, so the third use case, as I talk, like, these days machine learning and all these things are kind of buzzword. Everybody is trying all those things. So we also use machine learning models for fraud and things like that. We have a different use case where, we use user behavior, and we create machine learning models out of it, and we can assign some user-specific offers based on their, spending pattern or things like that, right? But again, it has to be trained. Like from the historical data we have to train that thing first. And in real time, like sometime, I mean, you might have seen this stuff. You swipe your card, and in the moment you get a notification that, hey, why don't you try something else here, right? So how that happens? Again, I mean, this is not powering it right now, but things like that you could do that with NIFI. So I don't have a dev snapshot for it, but in just like real some words, like how it works is, so there are two pipelines basically. One is for the training purpose, like you have like historical files coming in, and then we have machine learning models built on top of Spark. So we don't need very specific hardware requirements for it. We have built things on top of Spark. Again, like the files come in and it trains the model in an incremental way, and then stores the model. It could be a web service, or it could be a Redis database. And then there is a real-time flow coming in, a real-time transactions coming in, and we call the model. We generate a score. Based on that score, we assign some offers to the guy, and we respond back with other means. Could be SMS or email that, hey, you have been assigned this offer, you could use this offer. So this all happens in real time. So NIFI is basically supporting both the stuff, the training stuff, and the real time uses as well. Cool. So other than these are the three major use cases we are working on, but we are not limited to these things only. I mean, you can think of like a lot of data transfer use cases will be there in a company like Mastercard. So we are trying to solve most of them using NIFI. Again, we have like things like filtering and all that, like you read from one source and do some filtering and write to another source. So all those things we are trying to do using NIFI. Again, like some of the customizations we have did, like I said, like we have written processors. The messaging, what I mean in messaging is, we have a custom messaging solution which is built on top of Kafka in Mastercard. So we could not use like native Kafka processors which is there in NIFI. So we have to build things of our own. Again, like when we started, there was no Levy processor. Now it is there. So we built one Levy processor that time. We wanted to do things for time series. So we built a processor which could create split dimensions out of one transactions, and you can publish it to a time series database and do real-time monitoring or anomaly detection and things like that. And then we also tried this S3FS mapped repository. I'll give you like a brief introduction about it. In NIFI, there are things like provenance and content repository. Like provenance is like what exactly is happening, and content is actually what is basically moving inside the cluster, right? So we wanted to try if we could save that stuff to a remote location, just for like high availability perspective. So we used object store like S3, and we tried this S3FS stuff, and we found it was working. There was some performance issue, like the same flow which was finishing like in 3 minutes was taking kind of 5 minutes, but it was working. We didn't find any issues. Again, like few things which we are looking for is like full Kubernetes support. If it is there, like we have a push in our organization, like most of the stuff should support this Kubernetes deployment, and we are looking towards the community to provide this kind of support. And as you know, like what happens in NIFI is, it's whatever happens on a node stays on that node, right? So if that node goes down, and somehow if you lose that disk there, you are in a problem, right? So if somehow you could provide this data high availability between the cluster, like instead of just putting it on one node, if you could transfer or distribute among other nodes, so something like that on that terms. And third one is on usability perspective again. What happens in NIFI UI is you can go and see what is happening in the cluster, right? But in real world application, you will be talking to other NIFI instances also. There could be a minify instance where basically producing data for you, or you are transferring it to another a NIFI cluster, right? But if you want to manage that stuff at one place, it is not possible. So you don't know what is happening in all the other instances, right? You can build your own monitoring stuff and do that, but it is not possible right now to manage all the stuff in one UI. So something like that, if it is possible, and if community provides that, that will be very good. So these are the few things which we have done with NIFI, and these were some of the use cases which we have implemented using NIFI, and we hope we can solve many more problems inside our organization using NIFI. So with this, if you have any questions, I'm open to that. Yeah. Sorry, can you speak a bit? Mm-hmm. Oh, you mean like what? Yeah, so NIFI, when you say security, right, so it has to talk with, say, Hadoop clusters and all that, right? It does support all the stuff which is supported by that Hadoop distribution. So when you talk about this security, it's basically security between the NIFI cluster and say, Hadoop distribution, right? And it does support, like, it could be Kerberos, it supports all that stuff. So that is already there. So it's not like you will have to add anything specifically. It supports all those things, yeah. Yeah, please. So, I mean, as of now, we are using a lot of stuff. We have a lot of in-house built stuff, right? And obviously, I cannot say that we will be replacing all the stuff with NIFI. You know, there are multiple teams doing their own work, right? But this one, I feel, so far is the, I'll say, smartest solution. You know, you can go to production very quickly, and it's very manageable compared to all the other stuff we have. And it is cheaper. So, yeah. Yeah, sure. So I don't have any performance numbers here right now, and we did some in-house testing with that data, and we were able. So like we basically started looking into the number of transactions we are getting, right? So the peak numbers and all that, right? So we tried with that stuff, and I don't have exact number in mind, but it was like we were able to handle 30,000 plus records per second, and it's basically a real-time transaction, right? But I don't have the exact number. So I just said, like, you already like 3 use cases I showed, right? This is all there in dev and stage right now. We are working on production as of now. And we have a lot of other POCs also happening. So we don't think like we will have just one cluster and solving all the problem. We might end up with like multiple clusters for multiple different teams. It is possible. And one cluster will support some of the use cases. Yeah. Yeah. Yeah, please. So this is a good question here. I mean, specific to Storm, I will not say we have a use case for that, but we are thinking of integrating this with SAM, and SAM is another product which could be used with NIFI, and I believe that works with the Storm. So we are not there yet, but we have looked into it. But again, whatever you could do with the Storm, you could do it in Spark also, right? And we are already using a lot of Spark stuff. So if we end up using SAM, we might end up using Storm, but we are not sure yet. Yeah. Yeah, please. So right now, this is all open source stuff. Like whatever we have installed is all open source stuff using Ambari and all that. But we might go with that SDF installation in future. Yeah. So I mean, usually you will not want to use NIFI for that kind of stuff, right? You can do that practically. But you'll end up with a lot of problems. That's what I feel like. If you are, when you say ACID stuff, and you're dealing with the streams, it actually doesn't matter, right? Like if you're getting the transaction, you're just putting database. You're not doing a lot of ACID stuff here, right? If you're now things have moved towards like stream processing and all that, and their ACID doesn't mean anything, right? I mean, they are totally different terms there, right? So if you're using NIFI for those kind of things, obviously you'll not want to use any ACID stuff there. High number of transactions putting into database and doing all that kind of stuff. But if you're dealing with the streaming and all that, this is perfect fit for it. Yeah. Yeah. Yes. So whenever we deal with databases, right, we have to insert things in database. We do load balancing. So because your database stuff will be slow, right? And when we expose web service out of this NIFI, we have a load balancer in front of it, so that your your services are load balanced. So that is, we have a specific in Mastercard, like for all the other REST services, is basically a normal web REST service load balance, which is outside the NIFI. We are not using NIFI for load balancing. You could do that, but we are not using that. Yeah. Cool. Thank you all. Thank you for coming here.